All right, so continuing where we left off, we said the mean of the difference of the random variables is the difference of the mean, but the variance of the difference is the sum of the variances. All right, so let's take an example to contextualize this. Both Pete and Aaron run separate whitewater rafting tours. X is the number of passengers on Pete's trip. I know there's a lot going on here. You can always pause the video to kind of read through this on your own. Y is the number of passengers on Aaron's trip. The amount of money that Pete makes if he charges each passenger is $150. And D, the amount of money Aaron makes if she charges $175. So Pete, the mean number of passengers is 3.75 with a standard deviation of 1.09. And Aaron has a mean number of passengers of 3.1 with a standard deviation of 0.943. So remember, Aaron is charging 175 and Pete is charging 150. Find the mean and standard deviation of C and D, the amount of money that Pete makes and the amount of money that Aaron makes, given the mean number of passengers, standard deviation, and what they're charging. And then Pete and Aaron decide to join businesses, but keep their same pricing structure. Let E equal the amount of money they make. Find the mean and the standard deviation of E, which is the total of C and D. All right. So let's take this in pieces. You can pause here to read through this again. All right, so the mean and standard deviation of C and D. So the mean is going to be 375 times 150, which is what P charges. That's 562.50. And the standard deviation is 109 times 150. That's 163.50 for the standard deviation for trip C. For Aaron, the mean amount that she makes per trip is 3.1 times 175, or 542.50, with a standard deviation of 0.943 times 175. So remember, we're multiplying, when we multiply the values together, we're multiplying the standard deviation and the mean value. All right, so I have then the combined total, and this should be E, so this should be E. The sum of the means of the two mean totals that both Aaron and Pete pull in from each trip, 562.50 from Pete, 542.50 from Aaron, total of 1105. The variance is going to be, the variance of the total is the square of the standard deviation for Pete and the squared value of the standard deviation for Aaron. And then we're going to find the standard deviation for everybody by taking the square root of the sum of the variances. So be careful with this equation here. So remember, we can't just add the standard deviations. We have to convert it to variances and then take the square root. Sum and then take the square root. So the standard deviation of the total is the square root of the sum of the squared standard deviations for each, Pete and Aaron. So we end up with 232.31 as a standard deviation for the combined trip for Pete and for Aaron. All right. Okay, so this brings us to homework 6.2.3. You know, there's a complicated problem. All right, so we're going to go back to our original problem with Foothill and De Anza. So please read through this and I'll give you the answer during class. All right, so I'm going to move on. Okay, so we're going to combine normal random variables. Last part of the lesson. All right, so Mr. Otten likes sugar in his tea. From experience, Mr. Otten needs between 8.5 to 9 grams of sugar in his tea. That's a lot. for it to taste right to me. While making tea, Mr. A adds 4 random packets of sugar to his tea. The amount of sugar in the packets varies. It has a mean of 2.17 and a standard deviation of 0.08 grams. What is the probability that if I were to add 4 random packets that the tea would taste right to me? All right, so this is somewhat of a complicated problem, but I think after you see it, it will become less complicated. So I'm going to take this, remember, so I'm going to sum of the mean values for each. That's 4 times 2.17, so 2.17 plus 2.17 plus 2.17 plus 2.17, that's 8.68. All right, so the mean value for all the sugar that Mr. Otten will get is going to be 8.68. So now we need to find the standard deviation. So remember, now we have a little bit more of a complicated situation. The variance is equal to the sum of the variances. So I have to square 0.08, and then I have to add that 4 times, I end up with 0.0256. In order to get the standard deviation of the total, I'm going to take that 0.0256, take the square root of that value, it's 0.16. So now I have a mean of 8.68 and a standard deviation of 0.16 for all 4 packets. Now I'm going to find the z-scores for 8.5. So the mean is 8.68. The z-score is negative 1.13. Z-score for 9 grams is going to be 2. So I'm looking for z-scores that lie between negative 1.13 and 2. And so I find out that 12.92% of the normal distribution curve lies to the left of negative 1.13 standard deviations, and 97.72% lie below 2 standard deviations. So the difference is what's in the middle in the curve. That's 84.8% chance that it will taste right to Mr. Otten. So I'm going to leave this up here for you to think about, and then we're going to move on to, I believe, our last homework problem. Homework 6.2.4. Honeycrisp apples are approximately normally distributed. The mean of 9 ounces is a standard deviation of 1.5. If bags of apples are filled by randomly selecting 12 apples, what is the probability that the sum of the weights of the 12 apples is less than 100 ounces? All right. So I want you to do, I want you to answer this like you would answer an FRQ. And I'm going to leave this up here for a moment. All right, so that is it for our discussion for transforming and combining random variables. Thanks for joining us. Hope you have a great rest of your day. And you can come back and join us for the last part of random variables when we talk about binomial and geometric random variables.